If you're filtering water, you might be doing it backwards. Most people start with, which filter should I buy? When the smarter first question is, what are you actually trying to remove? Because PFAS is not one chemical. It's a big family of forever chemicals, and the best filter isn't the most popular one. It's the one that's certified to reduce the specific contaminants you're worried about, and that you'll actually maintain. Today I'm giving you a clean decision tree, how to check your water, what the new PFAS rules mean, and why they're still shifting, what filter types actually work, and how to avoid the biggest consumer traps. First, the big public story in 1 minute. In 2024, the US EPA finalized the first federal drinking water standards for PFAS, including enforceable maximum contaminant levels of 4 parts per trillion for PFOA and 4 parts per trillion for PFOS. The rule also set limits for other PFAS and used a hazard index approach for mixtures. Then in 2025, EPA announced it intended to keep the PFOA and PFOS limits while extending compliance deadlines and reconsidering parts of the rule for several other PFAS. Translation: the "this is serious" message is real, but the implementation timeline and some details are still moving. So for you at home, the move is not panic buying the most expensive system. The move is matching the tool to your situation, using third-party certification, and focusing on the water you actually ingest. Now, what are PFAS? PFAS are synthetic chemicals used for decades because they resist heat, oil, stains, and water. They're nicknamed forever chemicals because many persist in the environment and can persist in the body for a long time. The key point for this video is exposure route. For most households, the biggest concern is ingestion, drinking and cooking water, not showering. EPA explicitly notes only a small amount of PFAS gets into your body through skin, so showering and bathing are unlikely to significantly increase risk. That single fact saves people a lot of money. You often don't need to filter every drop in your house. Start with the water you drink. Okay, here's the decision tree. Step 1. Are you on public water or a private well? If you're on public water, your first stop is your Utilities Consumer Confidence Report, or CCR. That's the annual water quality report, and it's the most official, what's in your water, document you'll get. But here's the twist. PFAS data is often easier to find using EPA's UCMR5 tools, because UCMR5 requires monitoring for 29 PFAS plus lithium during 2023 to 2025, and EPA publishes results in a searchable database. If you're on a private well, EPA does not regulate it. That means you don't get a CCR, and no news does not automatically mean no PFAS. Your first step is testing guidance through state, local health or environmental agencies and a certified lab if needed. Step 2. Do you actually have a PFAS problem? Here's a calming but important EPA-style idea. If PFAS haven't been measured in your water, or results are low and below concern, a filter may not be useful for you right now. Don't spend hundreds based on headlines. Also, UCMR5 data is occurrence monitoring, not the same as formal compliance with the enforceable standards. UCMR is designed to show what's out there and where, while compliance is determined under the regulatory monitoring framework. So if you see a single detected number, don't instantly assume you're in violation. Think of it as a signal to learn more and choose a sensible exposure reduction strategy. Step 3. What are you trying to remove? This is where most filter shopping goes wrong. People see NSF certified or carbon filter and assume it removes PFAS. That is not automatically true. EPA tells consumers to look for filters certified to NSF, ANSI 53 or NSF, ANSI 58 for PFAS reduction, and to verify the exact model in the certification directory if you're unsure. And here's a critical nuance from NSF. Current PFAS reduction claims generally mean the filter can reduce PFAS to below 20 parts per trillion under test conditions. That's helpful, but it's not the same as guaranteed below the newest 4 ppm CL in your home forever. Now let's talk what actually works, the filter types. Filter type number 1. Activated carbon, GAC. Granular activated carbon is widely used and is one of the most studied PFAS treatments. It's common, relatively affordable, and comes in many household formats: pitchers, faucet mounts, under sink units, and sometimes whole house systems. The catch is performance and maintenance. Carbon can remove long-chain PFAS better than short-chain PFAS in many settings, and performance drops as the media gets exhausted. That's why certification and replacement schedules matter more than brand hype. Here's the LC rule for carbon. Carbon is a great option if you want lower upfront cost and you're disciplined about cartridge replacement. Carbon is a bad option if you buy it once and treat it like a magical force field for 3 years. Filter type number 2. Reverse Osmosis, RO. Reverse Osmosis is the highest confidence under sink option for many households worried about PFAS in drinking and cooking water. EPA lists RO as a PFAS reduction technology, and RO systems certified to NSF, ANSI 58 are a commonly recommended consumer approach. RO's trade-offs are real. It costs more, installs under the sink, produces reject water, and needs periodic maintenance. But if your PFAS levels are clearly elevated or you want the most confidence for ingestion exposure, RO is often the strongest consumer branch of the decision tree. One more practical point: because ingestion is the main concern and skin absorption is limited, point-of-use RO for drinking and cooking water is usually more rational than trying to RO your whole house. Filter type number 3. Ion exchange, IX. Ion exchange resins are a real PFAS treatment technology and are used in utility scale and some specialized setups. EPA lists ion exchange among treatment approaches and consumer filter categories for PFAS reduction. For most households, the buying process is less intuitive than pick a certified carbon or pick a certified RO. So our practical framing is: ion exchange is legit, but it's usually not the first simple consumer choice unless you're working with a specific recommendation for your situation. Now, the 5 biggest PFAS filter mistakes, so you don't waste money. Mistake number 1. Buying a filter before checking your water. If you're on public water, use the CCR plus EPA's UCMR 5 data finder. UCMR 5 covers 29 PFAS and lithium, and EPA's data releases represent about 95% of total expected results as reporting continues into 2026. Mistake number 2. Thinking NSF certified automatically means PFAS certified. You need the exact PFAS reduction claim for the exact model. EPA explicitly advises checking certification to NSF, ANSI 53 or 58 for PFAS reduction and verifying in directories if needed. Mistake number 3. Assuming a home filter standard automatically matches the newest EPA limits. NSF notes the PFAS reduction claim generally requires reduction to below 20 ppt, and standards updates are still evolving. That's not a reason to give up. It's a reason to treat certification as meaningful but not magical. Mistake number 4. Neglecting maintenance. EPA warns that not replacing filters on schedule can increase your risk of exposure. The best filter is the one you will actually maintain. Mistake number 5. Overbuying a whole house system for a problem that's mostly about ingestion. EPA notes PFAS are not readily absorbed through skin in meaningful amounts, so showering and bathing are unlikely to significantly increase your risk. That often makes point-of-use drinking, cooking filtration the smartest first move. Okay, so what should you buy? Here's the simple consumer decision tree in plain language. Branch A, public water, PFAS not detected or below concern. Don't panic purchase. Monitor updates, recheck your CCR annually, and use the EPA UCMR tools when available. If you still want a precaution filter, choose a certified product with a PFAS reduction claim and commit to maintenance. Branch B, PFAS detected, but you want a budget-friendly approach and simple setup. Choose an exact model certified activated carbon filter with a PFAS reduction claim. Replace cartridges on schedule like your health depends on it, because in this case, it kind of does. Branch C, PFAS detected, and you want the highest confidence for drinking and cooking water. Choose a certified under-sink reverse osmosis unit, NSF, ANSI 58 with PFAS reduction claim. Accept the maintenance and the waste stream is the trade-off for stronger performance. Branch D, private well. Test first, get local guidance, then choose point-of-use carbon or RO based on results, budget, and maintenance reality. Final calm takeaway. PFAS is serious, but the fix is not, buy the most expensive filter. The fix is, check your water, pick a third-party certified solution that matches your exposure, and maintain it. If this helped, hit like and subscribe. Check the description for the tools and affiliate links that match today's episode, plus our Longevity Compass Amazon KDP book. And tell us in the comments, are you on public water or a private well? And do you want a budget carbon setup or a maximum confidence RO setup?